There we go. So the last time I saw you, we were talking about slope intercept form, right? And we were trying to get things put into the form where we had slope intercept. And because mathematicians are not all that creative, when we name something, it usually has everything in it, right? We had a slope and an intercept. It was that y equals mx plus b form, right? And we knew that m was our slope and b was our y-intercept. And we were able to use that to create graphs, right? And we weren't always given the slope or the intercept, right? We had to find the slope. And if you remember, we had a formula for finding the slope, which was m equals y2 minus y1 over x2 minus x1, right? And we were given 2 points, and from any 2 points, we could find the slope of that line. Today, what we're working on is writing the equations of lines in slope intercept form. And we want to be able to do it if we're just given 2 points or if we're given a slope and a point. Right? The idea is to get it to this form. Why? Because this form is so useful in graphing the equations of the lines. Right? So, for starters, if I am given a point and a slope, so say I have -1, 7, and I know that my slope is m equals -4. I want to take these 2 pieces of information that I have, and I want to write the equation of the line. I just want to make sure that you see what it's going to look like when you're asked. That has a slope, right? M equals -4 and passes through the point of -1, 7. Now that's the question that you're going to be asked, right? That's what they're going to be asking you to do. Write the equation of a line that has a slope of -4 and passes through the point of -1, 7. Now, if I am given a point and a slope, we can always get to that y equals mx plus b form by using what we call the point slope formula. There is a formula that's going to get us from here to that y equals mx plus b form. And that formula is y minus y1 equals m, our slope, times the quantity x minus x1. Now, it is called point slope formula for a reason. To use it, you need a point and you need a slope, right? Excuse me. We were given both of those pieces of information, right? We have an m, our slope, which equals -4, and we have a point, right? I can call this point x1, y1, right? All this is telling me to put in the x value of a point and a y value of a point and plug in the slope. I can take these pieces of information that I have and plug it into this formula. And when I solve it for y, it gives me that slope intercept form that we kind of covet, right? Why do we covet it? Because it's the easiest thing to use. So here I have a formula, and here I have a point and a slope. I'm just going to plug those pieces of information into this formula. I have y minus, what's my point? 7, right? This is my x1. This is my y1. I have it labeled up there, but it's probably easier to see right here. So I have y minus 7 equals m. What is our m? It's -4 times the quantity x minus our x1. Well, our x1 is -1. I always write in both the negatives because it reminds me to add, right? So if I look at this, the first thing I'm going to have to start doing is distributing. The whole idea is to solve this for y, right? We're going to solve for y, right? We want y to be all by itself on one side of the equal sign. First thing I have to do is distribute. Well, the first thing I have to do is look at this and understand that negative like this together gives me a plus, right? So I have y minus 7 equals -4 times x is -4x, and -4 times 1 is just -4, right? The only thing I have left to do to solve for y, to get y all by itself, is to get rid of this 7 that's being subtracted from it. So I'm going to go ahead and add my 7 to both sides. And I get y equals -4x. Minus 4 plus 7 is 3. And we've got that form that we were looking for, right? If we wanted to graph it, it would be super easy to graph because I have my y-intercept, right, at +3. I just feel a need to graph it right now, right? If I wanted to graph that, I go, okay, well, I have a point at 3. My slope is -4, so that's like -4 over 1, right? And I could go down 1, 2, 3, 4, and over 1. And I have 2 points, and I've graphed the equation of that line, except for I'm actually supposed to run that line through both points, but I missed entirely. But you get the general idea of it, right? So given a point and a slope, think about it. It's asking for a point and a slope. It's the point slope formula. If you have a point and you have a slope, this is the formula for you. But what if you don't have a slope? What if you just have 2 points? What if I just had 2 points on this? What if I get a question that's like, write the equation of the line that passes through. This is a terrible S. The points. I don't know. What points am I going to use? Let's use -6, 1 and -3, 7. So I know 2 points on a line, right? And I want to write the equation of a line. If we look at what we did the last time, we were given a point and we were given a slope. So we could use the point slope formula. Well, if we look at this one, we're given 2 points. So we have the point portion that allows us to use the formula, but we don't have the slope portion, right? So we can't use the formula because we don't have the slope. But can we find a slope given 2 points? Sergio says yes. Who agrees with him? Jameson agrees with him. I agree. Valerie, why not? We have a formula for slope, right? If you remember, we have this formula that says m equals y2 minus y1 over x2 minus x1, right? M is our slope. This is our slope formula. We're given 2 points. We can call this one x1, y1. We can call this one x2, y2, and we can find the slope of those 2 points pretty easily, right? So I'm going to look at that. Well, what's my y2? Y2 is 7 minus my y1. Well, that's just 1. Over my x2, well, that's negative 3, minus my x1, which is negative 6. Note, I wrote in both negatives to remind myself to add, right? If I put those together, right, that becomes a plus. 7 minus 1, that's just 6. Minus 3 plus 6, that's just 3. 6 divided by 3 equals 2. So now we have a slope and we have 2 points. So we have an abundance of information now, right? If I want to use that point slope form, that y minus y1 equals m times x minus x1, I have all the information I need, right? Not only do I have a slope, which is 2, I have 2 points on that line. Which one do I pick? Any idea which one I would choose? America, you're sort of right. I don't pick both, I pick either, right? It doesn't matter which one I pick. They're both points on the line. No matter what point I pick, I can use it to write the equation of the line, right? They're both fine. So I can pick either one of these. I'm going to pick the one that's already labeled x1, y1. But it doesn't matter. I could have used this one if I wanted, right? And now I'm just going to fill in the blanks. Well, here I have y minus y1. Well, what's my y1? My y1 is just 1. It is hard to say y1. It sounds like it's wrong. Equals m. Well, we know what our m is. M is just 2. Parentheses x minus x1. Well, my x1 is negative 6. Make sure you put in that double negative so that you remember that this becomes an addition problem. And now we can solve pretty easily, right? This becomes addition. And I have y1, y minus 1 equals 2 times x, which is 2x, 2 times 6, which is plus 12. And the only thing I have left to do is to get that y by itself, and I have that 1 being subtracted from it. So I'm just going to go ahead and add 1 to both sides. Y equals 2x plus 13. Does that make some sense? All right, we're going to do one more together, and then I'm going to have you guys do one on your own. All right? So we are going to write the equation of the line that passes through. I'm not going to write out the whole spiel this time. I'm going to have 2 points. We're going to have minus 2. I should be saying negative 2 and negative 2. And negative 6, 8. So we have our 2 points. the first thing we're going to do, given those 2 points, is we're going to find the slope, right? We're going to find the slope, and then we're going to put in point slope formula. And then we are going to solve for y, because that will give us the slope-intercept form, right? These are our steps. Find the slope, put it into the point slope formula, solve for y. So the first thing we need to do is find that slope, right? Given 2 points, we'll find the slope first. So I'm going to go m equals, we can make this x1, y1, x2, y2. Doesn't matter, right? I can use either one. And we're going to go, okay, well, our y2 is 8 minus our y1, which is negative 2. Keep that in mind. That's 8 minus 2, so that's like 8 plus 2. Then we're going to go x2 is negative 6 minus 2, right? So that's like 8 plus 2, which is 10. And I have minus 6 minus a minus 2, so that's like a plus 2. Minus 6 plus 2 is negative 4. Note this fraction right here, everything is divisible by 2, so I'm going to go with minus 5 halves. So I have a slope, I have a couple of points. We get to use that point slope form now, right? That point slope formula, which is y minus y1 equals m times x minus x1. Now we're just filling in the blanks. I can use either point. I'm going to use the one that's already labeled x1, y1, but it doesn't matter. It doesn't matter which one I use. So we've got y minus y1. Well, our y1 is just negative 2 equals m. Well, our m is negative 5 halves times x minus our x1. Well, our x1 also just negative 2. Right? So we have our formula filled out. Now we just have to solve everything for y. We've got to go through the process. So this becomes y plus 2, right? So I'm just going to rewrite it for right now as y plus 2 because we need to deal with this distribution over here first. But this is also a plus. Minus 5 halves times x is just minus 5 halves x. Minus 5 halves times 2, well, that's like saying negative 5 times 2, which is negative 10 over 2. Right? So think about this. This is like saying minus 5 halves times 2 over 1, and it becomes negative 10 over 2. I can reduce this fraction, can I not? What's 10 divided by 2? Yeah. So I'm left with y plus 2 equals minus 5 halves x minus 5. The last piece I have to deal with in solving for y is getting that 2 off of there, right? So I'm just going to subtract 2 from both sides, and I get y equals minus 5 halves x minus 5 minus 2 gives me minus 7. This is the equation of the formula that we were looking for, right? Gives us everything we need to graph it. We have a y-intercept, we have a slope so we can find the next point. This is a perfect equation of a line, right? And we went fairly slow with it. I am going to have you guys do one. And then I'm going to have you put your solutions into the chat box once you find them, right? The first thing I'm going to do is I'm going to give you 2 points. So let's go with trying to look at my solutions to see kind of how they play out for you. I don't like that one. The one I have has like a lot of fractions in it. Let's just make up a point. Given 2, 4, and negative 4, 3. Right? The first thing I want you to do is, let's see, what do we need? We need to find the slope. And then you need to put in the form, right? Put in point slope formula, which I will write here. Right? The y minus y1 equals m times x minus x1. And then you want to solve for y. Right? I'm going to let you guys get to it. I'm going to raise this up a little bit so that you can see the problem clearly. I just made this problem up on the spot, so I don't even know it. I'm going to come over here and do it. The first thing I want you to put into the chat box when you get it is the slope. Ooh, we're going to get a fraction on this one no matter what. And we got to solve it. This will be my test on you guys to see how well you handle fractions. Anybody else have any other slopes coming up? You guys are all on the right track with it, but it's the negative 1/6. A lot of you forgot missed the negative on it. Jacob was right. Yeah, he's the only one, he put in the negative. I mean, clearly you were all doing the math right. You just left off, some of you just left off your negatives. This is just like my little tester to see how well you guys handle your fractions. How much you guys panic when you see a fraction. Because now as we distribute, you're going to wind up with a fraction when you plug it in. Where'd you do summer school, Jacob? Um, a negative over a negative, yes, would be positive. I always prefer the fractions, Madison. They're so much easier to work with. I know some of you guys like decimals because calculators put out decimals, but when I have my classes in person, I like to hit you guys hard with the fractions because I want you guys to have a really good understanding of how fractions work. Because decimals, when you move into higher math, are really, really difficult to work with. I do keep popcorn in my classroom. I keep microwave popcorn in my classroom so that students can just grab a bag of popcorn and pop it. Yeah, you guys miss out on being online. No popcorn for online students. And Shaylin's in here, so she could actually go grab a bag of popcorn out of the cabinet at any time and just go throw it in the microwave. Well, popping it in class can be loud, but the eating is not so bad. I just teach film. On Wednesdays, I have a film class in person. And so I feel like if you have a film class, you got to be able to eat popcorn during it. Yeah, it's a lot of fun. Wednesdays, period 2 through 4. How you guys doing with that equation of the line? Anybody find anything yet? Cadence, how you doing over there? Like a little mosquito. Yeah, it makes it really nice for film class because trying to watch it in 46-minute increments would just suck. Cadence, did you find your slope yet? This is me calling on people who I haven't seen their names pop up in my chat box. All right. Did you feel that? No, it's them slant like something happened next door, but it kind of felt like one. Jeremiah, did you find your slope yet? Oh no. Well, you're back, or are you on your phone now, Renee? Jeremiah, did you find your slope? Did anybody find the equation yet? Let's see. Who else hasn't been in my chat box here? You know, I have a dude that's been in this class since the very beginning of the year, since the first day of the year, and he's never shown up. How do you just like not go to school ever? Anybody have like any semblance of, oh, we got something up here. You were almost there, Madison. The only thing you have to do now is move over that. Well, first of all, that's an excellent start. But you forgot to distribute the 1/6 to the 2. Hey, no, you're the first one who's given me something to go off of, right? And then once you distribute that 1/6 to the 2 as well, you just have to move the 4 over. All right. Valerie, your variables disappeared. I'll go over that with you. Okay, America? I just want to see some people's you know what? I'll go over it with you right now while we still have time. Actually. So everybody got to the part, it looks like, where we found the m equals negative 1/6, or most of you did, right? So we've got our y minus y1 equals m times x minus x1, and we're just plugging numbers in now, right? Our y minus, let's see, I'm going to use, which did I use? I used the positive ones, right? The points that were positive, which were 2 and 4. Why did I choose those? Because they're all positive numbers. I don't have to worry about anything. Equals negative 1/6 x minus, what was it, 2? So y minus 4 is going to stay the same for right now, but we're going to distribute. And that's going to be negative 1/6 x. And then we're going to have to distribute here too. Well, that's going to give me a positive 2/6, right? If I reduce that fraction, it's actually 1/3, right? So I can go y minus 4 equals negative 1/6 x plus 1/3. The thing I have to do is I have to move this 4 over. I have to add 4 to both sides, right? Which means what? To add 1/3 and 4, I have to find a common denominator, right? So think about that. I have 1/3 plus 4, right? Think of it as 4 over 1. What would my common denominator be? It could just be 3. Right? Think about that. Yeah. Why not make it 3? It could be 12, but then I have to change both of these, and 1 goes into 3. So I'm just going to multiply this times 3 over 3. And I would have 1/3 plus 12 thirds. Right? Which gives me y equals minus 1/6 x plus 13 thirds. That is the equation of our line. I know. That's why I like to have you guys work in fractions. One, because I want you to learn fractions. If you can learn fractions really well, the ins and outs of fractions, you will be so successful in higher math classes, right? Fractions are they sort of level the playing field, right? They're where everybody started screwing up in math. Really, when you think about it, that's where you got to that point where you're like, I'm just confused. And I teach 11th and 12th graders, right? Algebra 2 and pre-calculus, and I still have students that go into a panic when they see a fraction or they plug it into a calculator and try and make it a decimal. But if you can get comfortable with fractions, oh my God, you can rule the world. Yeah, I did know that. That line in a division sign or in a fraction, this says 3 divided by 3. The division sign is a fraction. It's saying this represents a number over a number, right? It's whatever this is, 3 divided by 4. Oh no, I hope it doesn't keep you up too late tonight. You do have an assignment in Delta Math. This class is over. I just heard the bell. So I'm going to really quickly stop recording.